So is gravity going on in here?
What?
So again,
Gravity falls.
that a lot of you guys don't understand the projectile function. The projectile function is one of the most important thing that in terms of physics. In terms of physics, that you are in physics you're gonna deal with two dimension, which is x or y, which is I'm throwing something from here to Courtney catch. Okay, so like this, right?
That was a good catch.
And throw it back.
I'm gonna look in front of the camera.
Sorry.
That was amazing, Courtney. Oh my
Sorry.
god. Chad, did you see that?
Okay, so that is two dimension, right? That was two dimension because I not only throw it upward, I also throw toward Courtney. Okay? Yeah. You wanna try? So the projectile is gonna go in up and come back down. So what we're gonna do is we're gonna throw the marker this way. We're gonna throw it up and come back down. Okay? But first of all, to understand a lot of things. First of all, understand that I think it's Galileo went to the Tower of Pisa, says, let's drop a wooden ball.
Is that how you say it?
Pizza. No, it's Leaning
Pizza?
Tower.
Oh, I was gonna say.
Okay, so he dropped the pencil and he dropped maybe a iron ball and see which one's gonna fall faster. So which one falls faster?
The iron ball.
The iron ball should be falling faster? No.
Yeah.
The pencil should fall in same speed as the iron ball.
Yeah, but since there's an air.
Yeah, so air resistance doesn't count at this point. If you drop a piece of paper, then that's different. So if you drop a piece of paper, the paper is kind of like this, and go on the ground, so it really doesn't follow a thing. But if I drop one is super dense, a gold ball, and maybe a paper ball, not paper ball, but maybe like a tennis ball, if I drop at the same time, the goal is much more heavier but does not fall faster. Gravity is gonna pull exactly the same strength on both of them. Okay, that's what Galileo discovered. But and Galileo is also calculated speed, so how do I calculate the speed? How do I calculate velocity? So let's talk about, I keep on saying like there's a movie, I think The Journey to the Center of the Earth with Brendan Fraser.
Favorite movie.
Okay, it's one of my favorite movies. And he was going down to the cave, and the cave he doesn't know how far down, so he kind of had to test it. And he tested by dropping a glow stick into the hole, into the cave, and see how long it takes to hear the sound travel backwards, and to see how long the distance. Do you know how did they come up with that equation?
It's like, I've seen it always in movies.
Yeah, you see that always in the movie.
One Mississippi.
What's the name? Ice Age?
Yeah, one Mississippi, two Mississippi. But basically, they come up with these two things first. So we're going to talk about what is the gravity. The gravity, in terms of the matrix system, is going to be G is equal to negative 9.8 meter per second squared. And that's in matrix system. That's why Zachary is coming to show up. Says, can I do this in matrix system? No, because the reason why I don't want you to do matrix system, because I'm going to teach you the British system. The number is much easier to work with. Yeah, so the British system is going to be G is equal to negative 32 feet
Wait, I'm pretty sure you use meters.
per second squared.
Yeah.
Isn't it the
I don't know how to do it in the
I
British
prefer
system.
speed on units, dude.
They're the same units. They're the same speed.
Yeah.
It's just different unit conversion. So one is 9.8 meter per second, one is 32 feet per second. But there's reason why it's 32 feet per second in terms of math, because since you guys are not good at dealing with other number besides integers, so this one kind of give you an integer, which is nice. This one's 9.8, which is kind of disgusting. So then we're gonna have to deal with this in particular. But the projectile function in terms of the things is gonna be h of t. Okay, h of t is equal to half of g t squared plus v0t plus S0. This is in terms of physics. I'm gonna derive into the calculus formula, which is calculus, we're gonna use this one instead of this one. But in the physics textbook, you probably see is a negative 4.9 t squared, remember Zachary?
Yeah.
It's probably negative 4.9 t squared plus v0 t plus s0. That was in the physics textbook. But in terms of calculus, that we're gonna using the g as 32, so it's not gonna be 9.8. So h of t is equal to half times 32 times t squared plus v0 t plus s0, which is negative 16t squared plus v0 t plus s0. So last year you probably seen this before in my class. I told you guys this is a projectile function. This is the internal calculus. Okay? So we're gonna strictly using this. But we're also gonna stress something. We're gonna say, okay, h of t, we can use as or s of t. So it really depends on what teacher is using, what textbook. They might be using s of t or h of t. H of t is gonna give me height. So s of t and h of t, which is the height at particular time. Okay? And then t is equal to time. Usually it's going to be in seconds.
Can I move?
No,
Yes, you can.
you don't need to ask for permission, I don't care. So t is a time, but what is v0? Not just any velocity. Anytime you have a 0, please write this down. Anytime you see v0, that means initial velocity. That means initial velocity. Am I recording?
You are recording, sir.
Can you see the whole screen?
Yes. Yeah.
And S0 is going to be initial positions. Okay, so you got S of t of ht is the height at a particular time t. And do I need to conjugate anything, Nicole?
That one.
What? What do I need to conjugate?
Must be get through.
Conjugate.
Throws?
There you go.
Oh.
There you go. You would.
Okay.
He throw.
Yeah, it's still.
You're missing another conjugation.
Whatever. You understand my
Bro,
question.
imagine Spanish conjugation.
So now S of t, h of t, height at particular time, t equal to time in second, v0 is initial velocity, s0 is initial position. What else you need to know? First, on the calculus part, you need to know average velocity. Velocity. In this case, it's going to be s of b minus s of a. So b and a are the two separate times. B minus a, or h. In this case, this could be h. In terms of here, this is position at the time b. This is position at the time a. Just a different position. So for example, from here to your house is 5 miles, and for me to walk, it takes about an hour. So it's going to be the changing the distance, which is 5 miles, over changing time, which is 5 miles per hour. Does that make sense? So also known as what? Changing s over changing time. That's the average velocity. Okay? We're going to talk about instant velocity. I have no idea how to spell. A-N-E-O-U-S.
That seems about right.
Velocity is equal to, in this case, either is h prime of t or s prime of t. In last period, I forgot to address, there is acceleration as well. So acceleration it's gonna be h double prime of t and s double prime of t. So if I take another derivative, I'm gonna get acceleration, which is kind of makes sense. We're gonna talk about this. If I take a derivative, right,
Okay.
I'm gonna get what? Negative 16 times 2t, right?
Yeah.
And then there's a v0, that's the first derivative. The second derivative is what? It was negative 32t. If I take a derivative, it's gonna be negative 32, which is go back to here, versus gravity is same thing as acceleration. It was something movement per second squared. Okay, and those of you guys take physics, kind of help you in here. Anybody take physics in this room? Okay, so you understand what we're talking about, right?
Yeah.
But those of you who didn't take a physics, do you understand what we're talking about? Raise your hand if you don't understand.
Oh, no.
Okay, Courtney, which part you don't understand?
I'm trying to like understand it collectively, like what it's all supposed to, what it's all supposed to mean.
Okay, we're gonna show you how the application actually works until you get to that point. But here, just understand the notation wise, that I can have h double prime t, or because this is a height function, it's projectile, but sometimes I can use a position function. Position function could be a cars moving back and forth. Okay, so we can use s double prime t, s prime t. So that's the things that you understand, is to understand the big, small things first, and then we're gonna use the projectile first. Okay, now I throw a marker up. Okay, so if I throw this marker up, soon as the marker left my hand, I already have no control of the speed of the marker. Do you understand that part? So as soon as I toss it, right? Soon as I toss it, if I toss it, the marker left my hand, I already don't have the control of this marker at all. I don't have the speed, I don't have the influence of direction, I don't have influence of anything. Everything else is only determined by what? The gravity. Gravity is going to pull this marker down. So if I throw it, right? So if I throw it, as soon as the marker left my hand has some type of initial velocity. But why the marker, what kind of direction is that? V0, is it positive or negative? Going up is positive. So I have positive initial velocity. Does that make sense? Now, I can throw it downward too. If I have downward, then my initial velocity is going to be negative. But plus the acceleration, so that you have to take account. So sometimes if I throw it upward, boom, I throw it. The marker left my hand has positive velocity, and when I reach the maximum, what's my velocity? Why is the velocity 0? But why?
Slows down towards zero.
Why is it slowing down? What is slowing down?
Gravity's affecting it.
So you gotta understand, this gravity has a directional. It's going down, the marker is going up, but the gravity is always pulling this marker down since very beginning. Even that's how the marker is still in my hand. If I doesn't have the gravity, then marker kind of flow everywhere, right? It doesn't make sense because that's why the marker is on my hand. But when I go up to the highest point, my positive velocity start eating away by this gravity. Eventually gonna reach 0. This is very, very key idea. The velocity is reach 0 at the maximum height. And then at this point, my velocity is 0. But if I as soon as it pass the maximum height, my velocity is gonna be negative. And then gonna fall on the ground. I don't know if you've ever seen this picture, like a different shutter speed of a ball is throwing down. I think the ball started with like the first second, it was like this. And like it gets longer.
Oh, yeah.
Like if you look at a different shutter speed, the ball is dropped right here. The first second is gonna go only in trouble a little bit, 2 seconds, 3 seconds, 4 seconds. And it's gonna represent that way. Some people do like a glow stick dance, change the shutter speed, and they can draw a letter. So they're using that same type of photo skill that you can drop a ball. The ball is gonna be like going down at different speed because the shutter speed is different time and catch every different moment. Okay, so that is the idea. Last period I actually used a slow motion camera recorded me if I throw it, but I found out that's waste too much time, so I'm not gonna do that because I don't want to lose too much time. Because last period I was like in the part A when the bell rang. I'm trying to explain all of them in like 2 minutes and just didn't work out too well. So I don't want to do that. So do you understand what's going on? The gravity is always negative. I can throw it upward. I can throw it downward. It really depends. Okay. By the way, 64 feet per second. That's pretty awfully fast. You to play baseball, can you throw 64 feet per second?
No.
That's pretty ridiculous fast, right?
Yeah,
So imagine Mr. E is super
Fast
strong.
on the Wii Sport.
Okay.
Words are over real.
Imagine like Mr. E is super strong and the Mr. E is super short, like 0 height.
Oh, I don't
Okay.
need to imagine.
Yeah.
Oh.
You don't. Wow.
You didn't understand.
That hurts. Shorty.
At least tell you're really strong too.
I'm a super strong and I'm super small. So then what I'm gonna do is I'm gonna draw a picture of me like on top of the building. So this is the buildings.
So Mr. Yeah, gravity isn't real.
Isn't real.
Yeah, flat Earth.
It's actually just moving constantly
That's
upward.
true. Me is super short. Okay, just imagine that this is a 187 feet tall building. Why is it 107 feet? Because I'm roughly 5'7". So my arm, soon as I lift my arm here is 5 feet. Okay, we're gonna assume that's 5 feet. We don't wanna assume I'm like super small because they mean to draw that. So I'm at 5 feet and I chuck the ball up there and then come back down.
Dang. That's a far distance.
Okay?
Bro.
I chuck the ball as far as I can, okay, at 64 feet upwards, okay, upwards, okay, so it's going up, and we don't care about X directions because X direction is not relevant right now, we just care about how the Y direction. Also in physics, the only thing matter is the Y direction, because the Y direction can control how long the period I can travel.
Horizontal is constant.
Horizontal never change. So the vertical is what is gonna change. So are we okay here? Okay.
No. Wait, what do you mean by that? But like horizontal.
How do you throw the ball? Sorry.
Okay, so it doesn't matter how hard I throw it this way, like horizontal, which is the vector for the X direction or the Y direction. What it determines always the Y direction, because the Y direction, so if I throw a ball like this way, right, it's like 45 degrees, but my X direction is square root 2 of that, which is, then it's only the Y direction is matter, the X direction doesn't matter. But we're gonna get to that. I know it's hard to understand, but I'll answer that after school, I promise. So later I'm gonna use a marker to hit you and then you're gonna understand how that works. So understand this part. Understand. Okay, so Mr. Yad throw a tennis ball at 190 feet building, or he's 187 feet height, and he's at 5 feet tall. So it's initial height.
You're twice that speed.
Okay, throw it upwards. You gotta make sure underline the keyword. Shh.
43 miles per hour.
Shh.
That's slow.
That's really 45 miles?
43 mile per hour.
Feet a second.
Yeah, I throw faster
That's
than
that's
that.
really slow.
No, 64 feet per
I
second.
know.
That's what.
43 miles an hour.
Oh, okay. Then he can do it.
You can do it double.
Okay.
Oh, you're strong.
Okay.
So you went from super strong to like below average.
I thought it was super strong. Okay, so I should have converted first. So this part you understand? Okay, let's talk about the question. So the ball is up, and eventually gonna do a reach your maximum height, and eventually gonna hit the ground. You can understand that this is all relevant, and the whole picture is relevant. So let's go through the question. Part A. Part A says, hey, can you part A? Oh, I forgot to write down the initial part. So we're gonna write another part A here, which is maybe like pre-A. Pre-A. A prime. Okay, pre-1 is like right the projectile equation, write a height equation. Okay, so I want to write a height equation, and in this case, I'm going to do h of t, right? And we know over there is a negative 16t squared. Do you see that? Plus b0t. What is b0?
64.
64. That's initial velocity when time is equal to 0. That's how fast I throw up. Now remember, as soon as that tennis ball left my hand, I have no control over it. Okay, I have no control over it. So it's going to be plus 64t plus what? 192, right? Is we're going to call it pre-A. Okay, so before the first step, I really need to know that equation first. Now we're going to go answer all the questions. It says, find the time when the ball reached the maximum height. Time. So we want to find time. So find time when the ball
Equals 0 velocity.
is the maximum height. But we know at maximum height what's velocity.
0.
So velocity is equal to 0. So I find a velocity equation.
So it's equal to 0.
No. I find a velocity equation. How do I find a velocity? It's derivative. So if I take a derivative, I find that. So I'm going to take the h prime of t is equal to what? Negative 32t, good.
Plus 64.
Plus 64.
And that's it.
That's it, right? So, and we say that's equal to velocity, or instantaneous velocity. So that's also equal to velocity. H prime is equal to the v of t. Which in physics, they actually have just negative g plus v0. Okay? But now we're gonna set it equal to 0 because the maximum height, that same thing is saying velocity equal to 0. Because at the top, if I take a use 32 instead of 64, because the number is kind of hard to deal with. So then I solve for it, t equal to 0. Take 2 seconds for the ball to reach the height. Okay? Now part B. We say, hey, can you find the maximum height? Yes.
255.6 about feet.
I think it's a 256. I'm going to plug in 2 into the height. Because that means time equal to 2. What happened to the height? So I'm going to say, well, that means time equal to 0 equal to, what is the height? What is the height? That means we find out h of 2. Negative 16 times 2 squared plus 64 times 2 plus 192. That's equal to negative 16 times 4 plus 128, I think.
Yep.
Plus 192. That's equal to 64 plus 192. No, those two add together.
You know what? I converted to meters, so it's a lot.
So this is a feet, right? You have to pay attention to the units. I'm at 256 feet height. Okay, again, I'm still on the part. I'm not done yet. When the ball hit the ground. How do I find the time when the ball hit the ground? What do I mean by hit the ground?
Position equals 0.
Hit around.
Yes, h of t is equal to 0. So 0 equal to negative 16t squared plus what? 64t plus 192. Factor this. That's why I use the 632 minus what? 4t plus minus what? I think 12. So t minus 6 and then t minus 2 and 16. That's equal to 0. T is equal to 6. T equal to 2.
2.
Negative 2. Okay? So t can negative. So we don't worry about t is negative.
Yeah.
So we're going to cross that up. T equal to 6. Okay? So t equal to 6. Can I find out the speed at a time? If I have a d, can I find out the speed when the ball hit the ground?
Yeah.
Then I just plug in the velocity equation, right? What's the velocity equation? V of t is negative 32t plus 64, and v of 2 is equal to what? Negative 32 times 2 plus 6. I should plug in 6. 6. So 6 plus 64. So that's going to be what? 192 minus 64. So it's what? Minus what? What's a minus 192 and 64? So it'd be 8, I think. 128. So feet per second. You okay with D? E and we have to go is okay, I just record it. Average velocity just basically h of 4 minus h of 2 over 4 minus 2. I have no idea what is that. What is a 4? 4 is going to be what? Somebody up flat? F? That means the h prime of 3. Which is negative 32 times 3 plus 64. So that's equal to minus 32 feet per second.
No, today after school and today before school.
I don't know what's this.
Day, they get
Negative 16 times 16 plus 4 times 4 plus 192. I don't know, negative 256 plus 128 plus 192 would be negative 128 plus 192. That's equal to at 64. So 64 minus 2 will be what? Minus 16 times 2 squared plus 128 plus 192. So it'll be negative 64 plus 128 plus 192. That's 64 plus 192. That's equal to 256. 256 over 2. So that'd be 192 over 2. That's equal to, I think it's 96 feet per second.
Wait, isn't it negative?
It's negative. And that's it. What the hell are you doing here?
Oh my god.
Brendan, go away. You're getting fat. What did you eat?
everything.
How would that make you?
Why'd you try for try? Yeah.
You fat?
Why did you get fat to join the trip?
What did you
Yeah.
gain weight?
More velocity. He just he
Momentum.
won't run. He'll just fall.
Bigger gains.
You recording?
Yeah.
It was the perfect time for you to draw me.
Can you turn it off?